Oh, good, good, good. Now I will show you the bar plot, which is often used by the data people who deal with data. So the bar is bar. You see the first, say, for example, say labels, for example, use just say for labels, say first, then say second, or the third, some level say, okay, and I say some values. We'll use bar with levels. Okay, some values say 20, then 10, and then 5. Okay, so okay this, and now just I want to plot plt dot. You could also write say plt dot bar, and you could put labels, and then values, and then also color, all the same color. You can put different colors also. Say yellow, Y for yellow. Okay, and well, you can do that. You can now directly see that. Also, you do some other kind of style for later use. So I write this as say something as some variable. Then say birds equal to this. Okay. Now I can always do that. Oh, labels is not depend. Oh, I'm sorry. Labels. Okay. Labels. Oh, labels. Oh. Labels. Sorry, labels. Okay. Now I think okay. Okay. So now three the bars of yellow bars. This is the first. You can see first as per labeling, first, second, third. You could also write some numbers here. Doesn't matter. So this is for demonstration. Okay. So this is 2D bar. Okay. Now I can also do some more kind of funny designs, for example, that I only learned yesterday. So bars is a variable. So you write 0. Bars is now, you see, bars is now something entity which has 3 components. So bars, like the list you do, or numpy array you do, this is indexing. So bars 0 means the first one. So you give some say set some design, set underscore hatch, and this function. Okay, you don't have to remember anything, but you always find out something or the other. Just Google thing, huh? So it's by something, okay, and you can run that. You can see these hatch, these things are there. You can also do the next one, birds 1. You can write dot set hatch, and then with inverted comma you can write say star, and the next one you can write birds 2 dot set underscore hatch, and the inverted comma say golla. Okay, so now you see what it shows. Oh, so this is something. Well, okay. So now you can see that this is your presentation. You can do very many different things. You can see by help plt.bar, etc., etc. Now we can show you histograms. I will show you 3D plot, 3D bar also. Now, for the time being, I show you histograms. For example, if you write x equal to say np. So, I have to import first. I will use random number. So import from numpy import random. Then you write, say, for example, x equal to np. X equal to random, or you could write np dot random just like that. Random dot, say for example, uniform random number. So it is between say 0 and 1, and you create 1000 numbers. Okay. So uniform random number is from NumPy random module, and inside that there is a function uniform, and you create 1000 numbers. Okay. Now you just write plt dot histogram of those numbers. It will show you the histograms. X dot a comma 200. It will create 200 histograms. Bars actually. Color, and then you say green. Okay. So you you don't actually want to see that. I mean, it's unnecessarily showing me. So let me do that. Yeah. So it is the histogram. You can control that. You can you would see. You can tell that I don't want that many things. I want say 50 bars. So you can have 50 bars. So you can tell that I am on 20 bars. You can actually set their weight, etc., etc. Everything you can do. All these things you can do. So other day, our one good friend was asking about how to check a random number visually from the distribution. Should I do some collect the numbers from this to this, that, etc., etc., and can plot and can see whether this is a uniform or a Gaussian or whatever. I mean, you now see that if you are here, you now see that this is not required. If any explicit programming is not required. Everything can be done by the functions. So don't have to take any load on you. Okay. So this is this. And now you can do, say for example, I will do another thing. Mu equal to say 1. Why I write it, you will understand now. Sigma equal to 5, and beans equal to say 50. Mu and sigma nothing but if you have used normal distributions, means what we call Gaussian distributions in physics. Mostly normal distribution is given by two numbers. Any normal distribution, the mu is the population mean, means the peak value, and sigma is the standard deviation, means how wide the distribution is. And bin size, bins I call 50, etc., etc. I can actually give these values beforehand, because as if I am writing a program, full-fledged program. X equal to np dot random, not np, np random dot normal. There is a function called normal. It will give you normal distribution 1 to 5 and 1000 or say 10,000. Okay, X, and you have to write plt dot hist, and then you give X, then you give bins. Bins means already 50 bins, where it was this. You could write with this keyword, but I write it's bins because I control from outside. Bins, and the color is equal to say suppose magenta, M for magenta. For example, you can see lots of various fascinating colors are there. I will show you even more that. Normed equal to 1, that means it is normalized. All these things are here inside. If you type help inside that, you write plt.hist, you will see everything. And then R width equal to 0.8, and these hist also you write hist type equal to bar, it's a bar type, etc., etc. So you can also his type, you can actually write step, you can write bar, etc., etc. The way it shows you. Okay, so this is this. If you now see the plot, again I have to write plt dot show, otherwise it is unnecessarily showing me all the information. I don't need that. Okay, so this is your histogram. You see the normal distribution you have taken from here. And I could write here, mu, and I could write here sigma. Okay, so you see that. You see this normal distribution. So now it is clear the distribution. It said normal, whether it is normal or not. Okay, now I'll do some more fancy stuff. Say beans equal to 30 and x equal to in random dot rand in. Random is another normal distribution. N for normal. So here inside you write 1000 and then 3. Okay, let's see what it will create 3 sets of normal distributions, normal numbers, normally distributed numbers, and each of size 1000. If you want to see what is x, just print x. You see there will be 3. One, so it is a 2D array basically. It's a 2D array, and one is this, another is inside this, another is this. Okay, 3 sets of these things. Okay, so okay, well, so now I want to give it a set of colors. Colors equal to everything multiple values I want to give. I want to give as a list. That is quite normal. So I mean list or sometimes a tuple or array or whatever. List is more common. So blue, and then comma, then say green, and then the red. You know these young people, you may or may not know this green, blue, red, RBG, red, blue, green. These are the 3 fundamental colors. Lots of literature are there on this. You can create any color out of these 3 colors. So these are the often you see these 3 colors are mixed in a specific way to create any kind of color spectrum. Okay, so this now this plt dot hist. Inside that you write say x is your data, and you beans, you write the beans, 30 beans for each. Then you give level, and level equal to colors, and then I do another thing. I will plot 3 distributions, one top of the other. It is called stacking. Stacking you already have known from NumPy arrays. Anando probably have said yesterday. But anyway, you just remember this stacking. Normed. Stacking is a very common name. Normed is 1. And you can also you can also put fancy stuff, edge color. It's for designing part, and the say black. Okay, so that way you complete this thing. You could put lot of other things, and now see what it does. Again, I don't want to on this. Yeah, ELP dot show. Now it's this. Here I go here again. See here some fancy plots for whatever you use. You want to compare these 3 things, of course, and the first one, the second one, the third one, stacking on top of the other. Suppose in some situations you want to show some way that okay, this is what it is. Okay, so this is the fancy histogram plot, and okay, you want to now I'll show you 3D bar plot. Okay, let's see. Actually, I wanted to show contour first. Okay, let me see whether I can show you the contour plot first. Then I will go to the 3D plot, and then I'll come back to 3D bar diagram. Oh, before that, I have another thing, very important diagram, pie diagram. It's called pie diagram, right? PI diagram. Pie diagram. Pie diagram. Okay. So pie diagram. Pie diagram is nothing but you have set of data, and you write it in a circle so that the area of the 360 degree of the these things are the area of the total area, means total angle 360 degree is divided between the proportional to the corresponding data. That is it. So if you write say some data, sizes of the chunks of the pie of the circle, and you write say some 60, 15, 20, 3, 2. I 3, 2, 3. So the total is 100. You may not have to even write 100. It will adjust. It will proportionately. You will make it total 100. Okay. Anyway, sizes and then the labels. Labels. Say I write something. Say some rice. Say, and then sugar. Say, then say wheat. Say, and then how many? 1, 2, 3, 4, 5. Then cotton production, then and then say jute, etc., etc. So these are the labels. And now you write plt dot just pi, PIE pi, and then you write sizes. Then you write labels equal to labels. Labels is itself is a keyword, so I write labels equal to labels, and then write also you can do something some fancy stuff, but I will show you later. First you see whether it is done. Labels, it is oh, label must be length x. Oh, 1 2 3 4 5 1 2 3 4 5 1 2 3 4 5 sizes. Oh, spelling mistake. Labels. Oh, okay. Again, oh, lp dot show. This is not leaving me. Okay, so this is your pie diagram, and you can do some fancy stuff inside that. You can write, okay, you can explode something. Suppose you write here explode something, some say ex equal to some 0, 0, 0, 0.1 and 0. I'll understand what it is. And explode equal to ex. This tuple, this tuple or a list, doesn't matter. I write it as a tuple. So this explode means it will explode out. Let's see what. And you can also create shadow equal to true. These are designing part. True. And you would be also write auto PCT percentage. Automatically it will show you the percentage, the way you write formatting, string formatting, F, and then percentage. This is all these things are not important if you cannot understand everything. Oh, yeah. Oh, yeah. So these, see, the one part is exploded out. This cotton part. I mean the cotton part is exploded out, and there is a little shadow. This much it can do, and also the colors. You can. I have given colors. No colors. I have checked. I've given. You can select colors. Everything you can do. So there are also 3D plots. You can 3D pie diagrams. You can do not directly with matplotlib, but there is other module with the help of other module from somewhere. You can. I'll show you later other package. So with the help of matplotlib, you can show also fancy 3D pie diagram. Okay, now I will show you the contour plot. I'll show you the contour plot. Contour plot, and then increase the size. Contour plot, and okay, and mark down, run. Contour plot. Okay, now for example, you write x equal to np dot first I import in numpy. Import, I don't know whether I imported or not numpy as np. Imported, of course, but still x equal to np dot bin.
Abhijit, perhaps this is not required because this NumPy is already
Already, I know,
imported and
I
it's a
forgot
part of the sub same thing.
whether I cleared them or I forgot. So that's why I wrote. Okay, that's why I'm necessarily right. That's why our friends should understand that in this working in this Jupyter notebook, it's these shells. Once you declare or import one thing, it will remain forever. But sometimes I might have a habit of restart and clear output just to clear the memory. So sometimes I do that, so I forgot. Anyway, x.
Abhijit, there is a question that if there are multiple number of pie graphs, can radius be drawn with various
Yes. Of course, it can be
scales,
done.
or can size of the pie graphs be controlled?
Yes, everything can be done. I mean, the rest of the things are for people who will explore these things. Lots of things are done, but Kishore, I can tell you, there are certain things that you cannot. Not all everything can be done with their this matplotlib. I have found out that there are other packages which will go in tango with matplotlib and will create more beautiful plot. For example, there is Seaborn and other things are there which will create even fancier plots. Okay, so everything can be done. Everything on earth can be done. Let's make sure. No worry. Okay, perhaps I cannot show everything. I have to explore things like that. The necessity of is the mother of what they say, invention or whatever, convention, whatever. np equal to np dot. Okay, let's say y equal to x. So I create x and y data with the same size, square. And now there I create np dot, there is a function called mesh grid, and inside that I write x comma y. I'll show it. I have not drawn these things today. I'm running short of time, so I'll quickly can tell you this mesh grid is nothing but a grid. It's a grid basically. It's a graph paper. That means you have x and y data, and you see go by on the graph paper. You see say begin from 0, 0. Then on the x-axis you go say 1, 0, 2, 0, 3, 0, where y is all 0, 3, 0, etc., etc. Then on the next level you go up. That means it will be 0, 1, then 1, 1, then 1, 2, 1, 3, etc., etc. So that way you create a grid out of the same numbers. So your x is from 0 to say 10 or something here, 0 to 1, 10 points, and the y is from 0 to 1, 10 points, but it will be 0, 0, 0, 0, 1, 1, 0, 1, 1, up to 10, 10. From this corner 0, 0 to the another corner, left corner 0, 0 to right corner 1, 1. You imagine how you create. So this grid you have created with the mesh grid, function. And there are the two parts. The first part will go to capital. I mean, I rename it capital X. Another second part I rename it capital Y. So that's it. See, you can see that x and y. You can plot. You can print x and y. What are these things? If you want to plot, you check x. Say, for example, you check this. So these are the 2D NumPy arrays of x. There will be 2D NumPy arrays of y, and so on. So this will be necessary for your contour, because for contour plot, you will join the lines of the same density or same whatever. So you need to go through all these grid. Okay, you create. First you create this grid. Okay, and that's it. You now for each grid point, that's the junction points. So each xy junction point on your grid, you have to have some value. So the value can be plotted on the third direction, means z direction. Then
audio.
Is it okay? So you write, says capital Z equal to q star say np dot sine say np dot I star x. Say for example, no, it is capital X. You will see why. And star say for example, I just create something np dot sine and it np dot pi and then star y, etc. Okay, so this is your z, and you look at this. This is not small x. This is a capital S. Capital S means these 2D arrays. So this takes this 2D array. So it will create sign all this. That means I have now defined a value capital Z on each grid points. So given by capital X, capital Y. So that's the point. So this is again fake data, artificial data I am creating. And you now write PLT dot contour and then capital X, capital Y, capital Z. So this is what it is. And also you write PLT dot show, otherwise it will unnecessarily show you all this. Okay, now you run. Now you run, it will take time. Oh, so this is, it has created some, it is regular things. So it doesn't, it is something, we have created some regular things with sign X and sign Y. So it is the contour. If you want to write, say, contour F for filling. So you are filling in the with the turtle. Now it is F for filling. It will fill this space, and it will show you these things. Also, you can control the colors and etc. Everything you can do. But now geographers are here. They will obviously ask me, if I have a set of data, some data collected, how can I do the contour plot? That is not so easy. That is, I am reserving for tomorrow. For that, I need another package which is called pandas. I'll first introduce pandas, and I'll show this beautiful contour plot with the given or imported data. Here I am doing this with fake data. Well, I will use the same function, contour or contour F, and I will show this. I'll show this tomorrow with the actual data, imported data. Now I go for the almost the last of my talk. This is the third 3D plot. Okay, now for 3D plot, I need another module to import. PyPlot is for 2D plot. So I can write from, this is called MPL underscore toolkits dot mplot 3D. It was there in Matplotlib itself. Okay, so import, remember, import access. You can do very many ways, but you can do it this one. This is one way only. And also from Matplotlib import CM color map. It's for fancy thing, color map, CM for color map. This is another thing. Okay. So now I create a figure equal to, say, PLT dot. Of course, you may not write this, but since we have only one figure, but it is not required here, I create an axis. I can directly do that, but I create an axis. Axis 3D that I imported, axis 3D, and axis 3D. Inside that I feed figure. This is an argument. Okay, that's it. And now I have to write AX. I refer this axis, and write PLOT underscore surface. That means I want to put a surface. Of course, 3D plot, but 3D plot has to be the tent has to be given some surface, and the surface inside I can also inside the surface. Otherwise, surface I can put wireframe first. It's wireframe. It's a wireframe, typical wireframe, and then I write X, I write Y, and I write Z. Remember, these are capital X, capital Y, capital Z, created out of mesh grid, and then I can put some colors, red or whatever. Okay, so now you see, run. So this grid is created. These things is created. Okay. Well, you can write these. You can write these. You can take many data. Suppose you take, say, you can take 100 data points. 100 data points. It will be better. It will be better. It will be better. It will be better. It is more good. It will be these things. What is this? It will show you. What is not showing? Okay, let me check again. This. but it's not showing. It will show. Oh, I'm sorry. So this will show you. So this is this. Actually, you can write here on these pi, what is called Jupyter Notebook. You can write percentage matplotlib. It's a trick with which I can take this window out and see this. Run. You can create it. It creates a different window, and now you can actually hold this, and we can rotate this. We can interact with this. You could do it here. You could do the same thing as the 3D plot. You could do it here. You could do it here. Then you have to write it matplotlib. This you have to write probably in. I think probably you have to write no. You have to write inline. Inline means it would create the plot here, and you could manipulate. You could interact with that. Okay, but okay, outside is better. I see it outside to this, and also you can plot it with some fancy thing like say without wireframe. It's a better thing is surface. So actually I keep it for reference. Okay, I now copy. I'll now copy, and I now write this, paste, and I comment this, and now I write surface. SURFACE, surface. Okay, so and also the surface, basically forget the color. I have some fancy stuff because I imported this thing, CMap, color map. So I can write one scheme. Say write keyword is CMap, and the module is CM. So CM dot, there is, I like this cool one form. This is very nice. I like. It's my personal favorite. So it is this. So and you run this. You run this. So it's a fancy stuff. This looks nice. So this is your 3D plot. So you can do. I mean, you can actually delete these things, complete grid and everything on the scales. Just bear this presentation. You can bear this. You can do anything what you want. Okay. So this is about 3D plot, and the last part of my talk is today is the 3D bar plot. Let me see 3D bar plot. So now I go for here. I know 3D bar plot. So it is for 3D. Click 3D bar plot. Okay. Code, markdown, run. Okay. So now the same thing. 3D access 3D, and the same thing is same thing. Oh, already have done these things we have done, so I don't have to do that. So I write say random is also from numpy random. I need some random number. I'll use that. So figure equal to another figure, plt dot figure is, then you will show. I'll write ax equal to say pig dot add surface. Very many ways I can do that. I can add surface. Oh, sorry, subplot. Subplot. Sorry. Add subplot. I can add one subplot, or I can directly do that. 1, 1, 1 means this 1, 1 whole space and the one only. And the projection also you can write say projection equal to say 3D. You can do that. Lots of very many ways you can do that. You can just do it yourself and see. X position equal to np dot arrange say 1 to 11. So I'll create 1 to 10 numbers X position, and the position of the bars actually I'm creating. Y position equal to say random. Suppose I have actually imported random module from NumPy. So random dot say rand int, right? And inside that I can write say 1 to 10 and 10. So 1 to 10 numbers I create. The numbers will be values between 1 and 10, and the 10 numbers. This 10 is the number of numbers. Okay, and the Z position. Z position is actually it's on the ground. So X and Y positions are on the plate, and the Z position on the always will be 0. So all the Z's will be 0 unless you want a bar to lift a bit or so. So better I create np dot zeros into 10. You want to see what is np dot zeros? Uh, uh, Z position. Just check what Z position is. Zeros. Oh, matplotlib module no attribute fig. Oh, plot.figure actually. It is a plot.figure. That's why it's a plot.figure. Anyway. Oh, I didn't want that. I didn't want that. Yeah. See, this is, I just wanted to show. So this is, perhaps ADG has told you that is, or maybe because of time, if you have not shown.
No, I haven't.
You,
I haven't
you have,
shown the official function.
oh, okay, there's so many things. Okay, anyway, this is a fancy stuff. You can find out. It's go to NumPy and see this zeros means it will create how many number? 10 zeros you have just created.
All this is in the file that I shared.
Yeah. Oh, it is
Uh,
there. I know very much that these
It's
are
not there in the. It was not there in the text.
Okay. So now I created X position, Y position, Z positions, and now I create DX means the bars. I have to want 3D bar I have to create, and the size of these dimension of the bar DX, width of the bars. DX is np dot. I use another thing once. One means all 1 1 1 1 1, right? So if you write np dot once, it will be all 1 1 1 1 1 1. And I will say dy is similarly np dot. Oh, of course I could write the same thing. Okay, anyway, and I can write the dz equal to np dot lin space dz the height of these bars dz in the z direction. I can write 1 to 100. That means the value of the numbers will be between 1 to 100. You check it. I mean, you know it. Lin space, you know it already. 1 to 100, and there will be 10 numbers. Okay. So I create everything: dx, dy, dz, etc., and now I create the graph axis. Axis dot bar, the bar plot, but it will be bar 3D. And inside that you write x pose, you write y pose, you write Z pose, you write dx, you write dy, you write dz, and the color equal to, I found a very interesting color. How I will tell you. First I give it hash 32 PD. I think you will like the color. I'm not writing red, green, blue, magenta, etc., etc. I'll show you one thing here. For young people, you will something find. You can go to internet and see the colors are the hex codes of the colors. Okay, see the colors. The red regions are, these are the hex code. All these things you can see that. You can actually see that these are the red ones. These are the others. The yellow ones, the green ones. I probably chose some lime. I think I chose this lime green. I like that lime green, soothing color. You can always choose a fancy color for all these things. So everything is there. All these colors, fancy stuffs. So I put that color. Okay. So I put that color. Okay. Where did I go? Okay. Here I went. Okay. So 32, 32. That's it. And I write plt dot show. Okay. This is the last one, and this run. See the 3D bar plot is here, and you can now present it in your own way. See these are all randomly placed, and the bars heights are given by this dz, and dx, dy are the sizes of the dimensions of the x and y direction, etc., etc. So you can do lots of things, 2D, 3D, and etc., etc. Then later on, I mean, I will stop here probably, otherwise the convener will kill me. Anyway, I stop here. Thank you.
Abhijit, I have a question that once the image is generated, a corresponding hex code is there. And what is the use of those?
No, this is nothing. You do not. I do not have to do anything with that. Everything for whatever you do, so memory is stored in some memory space. I mean, for us, it is of no use. I think I have not seen any use, but for the developers, they can do it.
Okay.
And as far Anando can comment further, I think. And that's why I was not wanting that to always show. I mean, what is the use of that? Okay. If any more questions, I can go on. Otherwise, if anyone can tell anything. Okay. So tomorrow I want to show it. Tomorrow I want to show the base map that will deal with actually geographical plots, and the one important part that you have some data and XYZ data, and the data in the data you can do with the data you do the contour plot. These important two things I will show you, because before that I have to introduce pandas, of course, I think, at least for the contour plot. Well, okay.
Abhijit, you put me in a trouble, because tomorrow, whatever I have planned to say, you already told half of that. So I'm now in a trouble what to say tomorrow. Probably I won't say anything. We'll just continue the whole day.
No. You will show the statistical card fitting is important. Card fitting.
Come on, I do not know anything of statistics.
No, Runamada, you will talk about card fitting. That is very important for all the people.
Okay.
Card fitting is very important. You will show,
Okay.
and also
I'll
some
show
of arrays, statistics about the arrays or things like that.
Okay.
And show them the
I was just finding that if anything is left for me.
No. And also you please show them the SciPy statistics, which will be. I mean, we don't have to use here. People will find it their own.
Okay. SciPy statistics package is something very difficult. Even I cannot understand most of the things, because it's just for diffusionals.
Yeah, people who do lots of statistical analysis. All the I have seen that all things are there. Like every important statistical calculations are there.
I don't have much knowledge about all the statistics. That is the problem.
Yeah. Okay.
I don't have any knowledge about those statistics. You have given me a great.
You just show the Khoni. You just show the mine.
I don't understand half of it.
No. You don't have to. I mean, it's not our job. I mean, this some people who will use, they will find out. We will just direct them. People whoever use, particularly our friends from social science, geography, economics. Those people, they often use that. I mean, in physics we don't use much all those these things, but they will need it actually.
There was a question about optimization. That is curve fitting.
Optimization.
Would you like to show that?
Yeah,
Fitting, definitely.
Show the optimization and the polyfit, etc. The curve fitting part you concentrate. That is very important for.
Now will show the curve fitting tomorrow, I guess.
Yes. And I'll the first part I'll show the base map, and I'll just quit. Okay, that will not take more than 45 minutes or 1 hour.
And there was a question: can we plot elements of a sequence of real numbers to show its convergence divergence pattern? Anything. You can plot whatever you want to, as long as you know what you want to plot.
Question?
The question is,
I can see that.
You have to decide what the point is. The plotting is to be done by you, right? So you have to decide how you would plot it.
Yeah. Sure.
So you can do something even more. For example, you can show something like Fourier series.
Anything.
And show how the Fourier series individual partial sums converge. Can even do it dynamically as time goes by.
Yes.
And so on.
Actually, Anando, we could have. I don't know. I mean, we have not talked about animation. Animation is another important thing. We have maybe a little bit we can touch, and I wanted to show another fancy stuff, image processing, little bit. I don't know much.
You mean the PIL library or that huge thing? Do you mean the Python imaging library?
Yes.
Oh, that's huge.
No. I'll show you.
The two photographers will completely swamp us with.
It will for the photographers. It will, Kishore and I myself will enjoy. I think.
Might.
I have prepared, but I have no time to. Okay.
Abhijit, my suggestion is that if the time doesn't permit, but you had many things to share with us, what you can do, you can share the notebook version with in the WhatsApp.
Oh yes.
To prepare a notebook and just share that in the WhatsApp.
Yeah. No problem.
People can.
I think the background is prepared today about matplotlib and repeatedly
right. After this basic
tomorrow base map will
if you cannot complete things, you can share the notebook and people will understand.
Okay.
And of course, discuss on the WhatsApp platform.
Even tomorrow, I don't think taking everything, I won't take much more than 1 hour, because base map is something I'll just import and I'll show some map. And then afterwards, I'll show the image processing some 10 minutes. I have nothing much to show, just to excite these photographer people, just that. And then I'll leave it to you. After 1 hour, I think we'll give a break tomorrow. And then you will begin with your these things. I think then it will be okay. Not more than 1 hour. Okay. Okay. Any more?
Any questions from any?
Sir, I have a question.
Yeah, please ask.
Please.
Sir, if I want to include these files in a LaTeX file, how will I do it? How will I insert these files in a text file? These figures.
Figure. You mean the figure?
Yes.
So the usual figure so I have not shown one thing. You have generated the figure. You can easily save it. You can write plt.savefig. There is a function called savefig. Inside that, you give the file name and you write whatever. I mean, you can write this plt.savefig. I suppose you can see the screen.
Save underscore fig, most probably. Most probably save underscore fig. That's what I remember.
Maybe.
Not.
Yeah, let's see. The file name is paste.say.jpg. Whatever extension it will give, it will show. It will just. Let me see. It is actually not objecting. That means it will that means it is.
Yeah. Then it's right.
It is done.
If you right, then I was wrong.
If you read PNG, it will. Okay, tell me. It will show you.
The best thing is you just copy the figure. Just copy. Right click.
Right click. Save
copy image.
Yeah.
Copy image. Put it in anywhere.
PNG files, but it will create only PNG image. It won't give us create.
No, that way you lose resolution. It's actually SetPig is much more powerful. It allows you to do many.
Yeah. I think JPEG also can be done. I think I shall see it.
Yeah,
actually, you can say DPI, everything you can do. I mean, a lot of things I wanted to tell, but I could not. I mean, these things. So yeah. This is you can do this way, or you can directly right click and this is. And also, when you are doing on interpreter, you can see these things. You can see the control switches down the plot. You can always do that. Okay. And you can then, our friend asked, you can then incorporate this figure as usual in your LaTeX file. No problem.
We have 12 more minutes. You can ask your questions and whatever you want. I think there is no other questions.
Okay, then we can.
Then we can stop right here. So we have completed 7 days successfully. We will come back tomorrow again at 3 p.m. Thank you for now.
Thank you.
Okay.
How to?
Thank you.